So today we're going to start Chapter 5, Section 3, where we evaluate trig functions. This video, because the slides are long, this video is going to be broken into two parts. So part 1 will be slides 1 through 7, okay? And then from part 2, which will be a separate video, will be slides 8 through 12. So we're going to go back to the trig functions sort of as you learn them in geometry. In geometry, you learned all about SOHCAHTOA, okay? Sine, cosine, tangent. We're still going to introduce cosecant, secant, and cotangent, but we're going to go back to finding the sine, cosine, and tangent and the other trig functions using a basic triangle that isn't located in the coordinate plane to start, okay? So again, here, what we've got then is, our sine is opposite over hypotenuse, right? So the sine is opposite over hypotenuse. And of course, we learned the other day that it was y over r, right? We learned that opposite was y, adjacent was x, and hypotenuse was r. And so that works when it's in a coordinate plane. However, when we're doing just a random triangle out of nowhere, it's opposite hypotenuse or opposite adjacent and hypotenuse. So we're going to go back to that a little bit. So cosine is adjacent over hypotenuse. And so again, we write it adjacent hypotenuse. And again, on a coordinate plane, it would be x over r. And then we have our tangent, and our tangent is opposite over adjacent. Okay, so again, that's just to help us opposite over adjacent, and you know that that's your y over your x. And now we're going to do the same thing, the opposite, adjacent, and hypotenuse, but with our cosecant, our reciprocal values. And so we know that the cosecant is the reciprocal of the sine. So it would be hypotenuse over opposite, or r over y. We know our secant is the reciprocal of our cosine, so it's hypotenuse over adjacent, or r over x. And we know that our cotangent is a reciprocal of our tangent, so it's adjacent over opposite, and it equals x over y. So we're going to do a lot of work for the next few chapters using these ratios. So if I give you a problem like this, and I just give you a notice, it's a random triangle, it's not in a quadrant. We have two legs in this triangle. One leg is 7 and one leg is 24. And what we're missing here, obviously, is the hypotenuse. Now, it asks you to find the six trig functions. However, it doesn't tell you of which angle, and the angle matters. So let's just name this, for example, let's say triangle A, B, and C, and let's solve the 6 trig functions of angle A. So let's find the 6 trig functions of angle A. Okay, it's always the trig functions of the acute angles. So it's either A or B here. So the first thing we're going to have to do is we're going to have to know what our hypotenuse is. And so you can use the Pythagorean theorem for that. Remember, a squared plus b squared equals c squared. The hypotenuse is always c. So 7 squared plus 24 squared equals c squared. If you guys remember your Pythagorean triples, you're going to recognize that, or your common triples, you're going to realize that this is one you probably would have wanted to learn, or you should have memorized it. It ends up being 625 equals c squared, so c is the square root of 625, which is 25. And again, when you memorize these, it's really helpful because you automatically know the hypotenuse is 25, and you save yourself all this math, okay? But anyway, now we have that. So since we're looking at angle A, we're trying to find the 6 trig functions, and we're going to need to know which is the opposite and the adjacent for this. The hypotenuse, well, it's always the hypotenuse. Well, in this case, 24 is the opposite, and the leg next to it would be the adjacent. So for angle A, I have my values. Now I can do my 6 trig functions. So I can't just say the sine of, the sine equals, opposite over hypotenuse. What I have to specifically say the sine of what, okay? So you'll get it wrong if you don't. So I have to say the sine of A equals opposite over hypotenuse, and in this case, that's 24 over 25. The cosine of angle A equals, again, adjacent over hypotenuse, which equals 7 over 25. And the tangent of angle A equals opposite over adjacent, which is 24 over 7. If any of these improper fractions are what we want, but if any of these have to be simplified, you have to make sure you do that, okay? So now we'll do the reciprocals. The cosecant of A is the hypotenuse over the opposite. The secant of A is equal to the hypotenuse over the adjacent. And the cotangent of A equals the adjacent over the opposite. And so it's just the flipped version. And so those are the answers. And once again, you do have to make sure that, sorry about that, you do have to make sure that you simplify this final answer. It has to be fully simplified, okay? And that means if the denominator is a radical, it has to be rationalized. So again, we keep going here, and again, it asks, doesn't really tell us, again, we'll make this up, we'll give it a value, we'll call this angle A, we'll call this angle B, and this time we'll ask you for the 6 trig functions of the acute angle B. So let's say of angle B. Now to do that again, you're going to need to know your missing leg here, okay? This is angle C. So we don't know the length of AC, and so we're going to use our Pythagorean theorem for it. So again, remember it's A squared plus B squared equals C squared. A is one leg, the other leg we don't know, and the hypotenuse is always your C. So we get 1 plus B squared equals 4, so B squared equals 3. So I know that B is the square root of 3. So this leg is square root of 3. So again, in this particular case, I know that the opposite leg is this one. So there's my opposite, and I know the adjacent, okay, is going to be the 1, okay? So I'm going to use those in my 6 trig functions. So again, I come over to here, and I know now I'm doing the sine of angle B. So let me do sine, cosine, tangent, and then let me do cosecant of B, secant of B, and cotangent of B. Okay, so the sine again is opposite over hypotenuse, and so it's going to be square root of 3 over 2. Again, remember the hypotenuse is always the hypotenuse, right? The legs switch from opposite and adjacent, but hypotenuse is always the same. So that's my sine. My cosine is going to be adjacent over hypotenuse, so it's a half. My tangent is going to be opposite over adjacent, okay? And then my cosecant is going to be flipped, so it's going to be 2 over radical 3. My secant is going to be the reciprocal, 2 over 1 or 2. And my cotangent is going to be 1 over radical 3. And yes, I have to simplify these. So this is going to be 2 radical 3 over 3. And this is going to equal radical 3 over 3. So you do have to simplify. You cannot get around that. You have to rationalize your denominators and simplify your fractions. So we're going to get to special right triangles now, and I know you learned about this in geometry. In fact, we spend a lot of time in geometry on these special right triangles, and there's only 2 kinds of special right triangles. The first kind is a 45, 45, 90. What that means is the 2 acute angles are 45, and the third angle is a 90 degree. It's a right triangle. That's why they're called special right triangles. Because it's a right triangle that has the 2 acute angles, 45 and 45, are congruent, then we know that the 2 legs of this triangle are congruent. So our legs are, they have their value, and the hypotenuse is always the leg times the radical 2. So when I teach this in geometry, I teach you that I use the variable a, and I say, well, the side opposite the 45 is a, the side opposite the other 45 is also a because they're equal, and the side opposite the 90 is always a times the square root of 2, okay? So when you used to do this in in geometry, you might have done, like I said, you might have done something like this. You might have done A, and A times radical 2. And so I'm going to show you how to do it that way. But if you notice here, they use 1, 1, radical 2. All they're doing in this is they're substituting in. They're making A 1. So again, if A is 1, then the two legs are 1, and the hypotenuse is 1 radical 2 or just radical 2. And so it is the same concept as before. Some of you may want to use the A's, even though it becomes a little tedious down the road, and others may want to just switch over and use the whole 1, 1 radical 2 pairing. And I'll kind of show you why. I'll show you both. And then again on the right, you see that you have the second kind of special right triangle, which is a 30, 60, 90. One acute angle is 30, the other one is 60, and the third angle is always the right angle. And so this also has a special relationship with its sides. Now, when I taught this, again, in geometry, we taught it as the side opposite the 30. The 30 is the smallest angle, and we taught that the side opposite it is always A. The side opposite the 60-degree angle is always A times the square root of 3, and the side opposite the 90, or the hypotenuse, is always 2A. Okay, so this is kind of how we taught it, okay, 2A. So again, if you were in my class back then, you would have A radical 3, and 2A would be how you would do it. And again, I'm going to solve the problems at first using both methods, but what they did here is they just made A 1. And so if A is 1, then the side opposite the 60 is 1 radical 3, which is radical 3. And this one is 2 times 1, or 2. And so that's how you get to these numbers here, where the side opposite the 30 is 1, the side opposite the 60 is radical 3, and the side opposite the 90-degree, or the hypotenuse, is 2. So again, you're going to want to kind of transform or move into using the 1 radical 3 and 2, and like this one, the 1, 1, and radical 2. You're going to want to do that, but if you learned it this way and you're comfortable with this method, and I use A as my variable, but your teacher might have used S or X, it's the same thing. You can start that way, and then you can kind of transition. So let's see, it says find the following. So it wants the sine, the cosine, and all these things. And notice we're talking here about 30 degrees and 60 degrees. So I'm going to draw a 30, 60, 90 triangle, right? So this is my 30 degrees, here's my right angle, and here's my 60. Now again, I'm going to do it both ways. You can either say the side opposite the 30 is A, the side opposite the 60 is A radical 3, and the hypotenuse is 2A, or you can do the side opposite the 30 is 1, the side opposite the 60 is radical 3, and this one is 2 times 1, or 2. Okay, so I'm going to show you both ways and how they both work, and then you can, we'll do the next one. We'll do the first one both ways, and then on number 4, we'll get down to using the 1, 2, and 3, okay? So the sine of 30 degrees, if I'm at 30, I know the sine is going to be opposite over adjacent. So again, the opposite, I'm going to use the letters first, okay? So the opposite is A, and the hypotenuse is 2A. So notice if I do A over 2A, the A's will cancel, and I'll get a half. My cosecant is going to be the reciprocal, so 2A over A, and again, I'm going to get 2. My cosine is going to be the adjacent over the hypotenuse. Well, the adjacent is A radical 3 over the hypotenuse 2A. Again, I cancel out the A's, and I'm going to get radical 3 over 2. And my secant is going to be the reciprocal, so it's going to be hypotenuse over adjacent. So it's going to be 2A over A radical 3. I'm going to get 2 over radical 3. And then I rationalize my denominator, and I get 2 radical 3 over 3. My tangent is opposite, which is A, over adjacent, which is a radical 3. So it's 1 over radical 3, which is going to be rationalized to radical 3 over 3. And my cotangent is going to be adjacent over opposite. And so, again, those cancel, leaving me with radical 3. So if you look, if I use the A's, I get these 5 answers. I just had to cancel the A's out. They always cancel out, but it is a little bit more tedious. Now, let's try that same problem, okay, but let's do it using the numbers, the 1, the radical 3, and the 2, just so you can differentiate, okay? We already know what the answers are, so let's come back in. Let's do the sine of 30 using the numbers. It's opposite over, whoops, sorry. Okay, so this is opposite over hypotenuse. Notice I got the same one without having to cancel out the letters. My cosecant is going to be 2 over 1 or 2. Again, same answer, okay? My cosine is adjacent over hypotenuse, so it's going to be radical 3 over 2. Done. I don't have to simplify to get to it. So you're starting to see how much easier it is if you can just convert from using the A's to subbing in a 1 for the A. If I go to my secant, I know it's going to be the reciprocal, so I'm going to start with 2 over radical 3, which I know is 2 radical 3 over 3. Again, same answer, right? And then my tangent is going to be, again, opposite over adjacent, which I'm going to rationalize to this. Same answer. And my cotangent is going to be adjacent over opposite, which is just square root of 3. And so as you can see, I will get the same answers whether I use the blue, which is what I learned in geometry, A radical 3 and 2A, or if I use the red, which is 1 radical 3 and 2. As you can see, though, I think you can recognize that the numbers are the easier way to go. So now I'm going to do the next few problems, or I'm going to do them from now on using just the numbers. Now you know where they come from. And I think you've seen why the numbers are the better way to go with these, okay? So let me kind of set this up now using the numbers. So again, the side opposite the 30 is 1, the side opposite the 60 is radical 3, and the hypotenuse, whoops, it's not 2A, it's 2, okay? So now let's do our 60-degree questions down here. So now they're asking me for the sine and the cosine and all the 6 trig functions of 60 degrees. So again, the sine is going to be opposite over hypotenuse. My cosecant is going to be that flipped. So 2 over, or hypotenuse over opposite. And yes, I do have to rationalize this, so I do have to simplify this. The 60 degrees, cosine of 60 degrees is going to be adjacent, which is 1 over hypotenuse. The secant is going to be the reciprocal, which is just 2. And the tangent of 60 degrees is going to be, again, opposite over adjacent, which is square root of 3. And the cotangent is going to be adjacent over opposite. And I do have to rationalize that, so I'm going to get square root of 3 over 3. And so there are my 6 trig functions, or trig values of the 6 trig functions using, I think, the easier form, which is the numbers. Now, when I come over to this one, notice that we're doing the same thing. We're doing the 45, 45, 90 triangle. And again, you definitely want to draw it. You want to, when you get your assessments, when you're doing your work, you want to draw this out and you want to have it, okay? So 45, 45, 90. And again, I'm going to do it, I'm going to show you how the A works for the first one, and then I will show you the numbers, and you can pick which one you want to choose. So again, remember that with the value of the variable, remember that this is A, and A radical 2. If I was to do the numbers, I would sub in a 1 for A. So this would be 1, 1, and 1 radical 2, which is just radical 2. And so again, when I'm finding the sine of 45, I could pick any one of the 45 degrees. They're the same, right? But let's just say this one. It's opposite over hypotenuse, so it's A over A radical 2. which means these are going to cancel, and it's going to be 1 over radical 2, which simplifies to radical 2 over 2. So that's my answer. Now, had I used the numbers, again, this would have been 1 over radical 2. And again, I would have gotten radical 2 over 2. But I think you see the numbers, again, are easier. So we're just going to use the numbers for all the other ones. We can cancel out or ignore the a part of this. All we did is just subtract, basically substitute the 1 for a. And so now we're going to keep going. So again, the cosecant is going to be the reciprocal of the sine. If the sine was 1 over radical 2, the cosecant is going to be radical 2 over 1, which equals radical 2. The cosine is going to be the adjacent over the hypotenuse, which is also 1 over radical 2. So that's going to be radical 2 over 2. And the secant is going to be radical 2 over 1. It's the reciprocal of the cosine, which equals radical 2. Okay. The tangent is going to be opposite over adjacent, so it's going to be 1 over 1, which is 1. And the cotangent is going to be the same. It's really important, guys. It would be really great if you could just memorize that the tangent and cotangent of 45 degrees is always going to be 1. Okay, it's just kind of good. You can always do the math and, put opposite over adjacent or adjacent over opposite and get 1. But again, the more you can memorize, the better that'll be. But again, you know that if you know your triangles, you can always do it the longer way. You can always just set it up every time. Okay, so I am going to stop this video here at the end of this particular slide. So this will be the end of part 1, okay? And then I will upload a second video starting on slide 8, which will have the second part of this lesson.